Hello, everyone, and welcome to our webinar on exploring various Windows persistence techniques. And I'm Nandini Bharadwaj, the operating officer at CyberWarFare Labs, and I'm really excited to have you all here with us today. So let's get started. Okay, so before we jump on the main topic, let me give you a brief introduction about our company. CyberWarFare Labs is a UK-based edtech company. The company is committed to addressing cybersecurity challenges with a real-time, hands-on solution. Our virtual platform allows users to refine their skills through plug-and-play practical labs. So our company has mainly two divisions. The first is Cyber Range Lab. This is our unique selling point as this division focuses on providing practical, real-time solution to cybersecurity challenges. And it offers a virtual platform where user can engage on hands-on trainings through practical and theme-based labs that are ready to use. And the second one is upscaling platform. So we offer a wide range of on-demand courses in red teaming, blue teaming, purple teaming, and cloud security domains, designed for individual at all skills level, starting from beginner to intermediate to advanced. And our instructor-led training services are available to educational institute, government agencies, and corporate organizations. Both online and offline training options are available. To explore more, please drop a mail to our support team, support@cyberwarfare.live. Okay, so let's move on to next slide. So, let me introduce to our speaker of today's webinar, that is John Surgeon. Our speaker of today's webinar is John. He is a Red Team security researcher at Cyber Warfare Labs. With over 5 plus years of experience, he is an expert in reverse engineering, malware analysis, and Windows internal. Currently, he is focused on EV/EDR evasion projects. So that's all about the speaker. And dear participants, as promised, we are excited to share that you will receive your certificate of attendance within next 48 hours, along with the video recording of the webinar. But wait, there is more. Three lucky winners will have an opportunity to win access of our popular certification, that is Red Team CredOps Infiltrator CRT COI course, and the winners will announce shortly after the webinar. So stay tuned for that. And so thank you for being the part of this engaging session. We will look forward for your continuous participation. And from here, without further ado, I would like John to take over and let's get started. And yeah, thank you everyone. I hope you will enjoy today's webinar. Okay, over to you, John.
Okay, thank you everyone. Thank you everyone for joining, taking out your time and joining this webinar. Today's topic is all about the persistence, where we will be exploring the fundamental of the persistence. So, without further ado, let's start with the context itself. So, what is the persistence? Persistence, it's a tactic that is followed by the attackers to maintain the access into the compromised machines for the long period of time. And why do they uh, follow these tactics? So let's say when attackers compromise the system and their goal is to maybe ransom the computer, or maybe perform the espionage, or maybe exfiltrating the datas. So there could be many objective of the attackers based on their plans and campaigns. But to achieve to their goal, it takes time, and this is why the persistent comes into play. So sometimes, let's say, if attackers get into the machines, and we know that there will be frequent update in the machines, and sometimes the machines get rebooted or maybe there will be some changes in the configurations, or maybe the credentials that they may have compromised could be changed at some point, and they may lose the access to that machine. So this is what they do not want during their operation. They want to persist in the system so that they can move further into the network and achieve their goal. So for that, the persistency tactics it comes into play for them. So here are a couple of techniques that we are going to explore today, and there are numerous techniques. If you just go and look into the MITRE framework, you can see more than 80, 90 techniques listed there. But here we are just exploring in a brief, and this webinar will be short and sweet as well. So we are just exploring a couple of commonly used techniques. Okay, so let's start with the first one. So the first technique that they use is boot or lock on auto start execution. So whenever the Windows boot, so not only the Windows, but it will be in the other operating system as well. But here we are only talking in context of the Windows. So I may be using the Windows frequently, but something will be using the other operating system as well. So let's say when operating system boots, and there are some applications or scripts that a user want to execute so that they do not have to open the application frequently used applications or the services. They do not want that to open manually when the system boots. So in that case, the operating system they allows the users to register some applications or maybe some scripts so that they will be executed at the login time. And for the Windows registry is a favorite target for the attackers, and they persist by modifying the some keys or some registry keys to persist in the system. So there are a couple of techniques under this boot or login auto start execution, but we are going to look into the registry run keys and startup folder, but we are not going to look into the startup folder. After this webinar, you can go and explore because it's quite interesting, but we are only focusing the registry run keys for this webinar. So there are a couple of keys in the registry that is created by default by the Windows system. And these keys are there so that the user can give a program reference in those keys, so that whenever they log in into the system for the next time, the program that is referenced in that particular entity will be executed. So um, there are a couple of locations where you can add the entry. So these are the location of the run keys. One is the add key current user software Microsoft Windows current version run and the run ones. And then there is the another one which is the local machine. So current user means it's for the current user context wherever you are logging, and the local machine means for the every system, every users that are available in the system. So attacker they will add the entry into these run keys, and they will point that key to their malicious payload. And whenever there is a reboot next time in the system, the payload will get executed. So that's all about these run key techniques. So here in this registry key, you can see here in the registry run key, here the attacker will add um, some entry like for instance persistence, and then they will point to their payload, and another boot when there is the reboot, or maybe when the system boots for the next time, this payload will get executed. And here is the command that can add the this entry in this registry location. And yeah, this is how usually they do it. And if you have a GUI access, you can do it manually, going into this location from the registry editor as well. Okay, so another technique that attackers use is the create or modify system process. There are some system level processes such as service daemon agents running in the operating system. So this system level processes usually runs in the background, and they handles the operating system functionalities. They communicate through the networks, and they do bunch of stops in the background. And also the third party application can also register some services in the system as well. And one common target for the windows in the windows to so that attacker can persist using this services mechanism is the Windows service. And to register this service or to modify the service, attacker may require the administrative privilege for this one. Okay, so the sub technique that we have selected for this create or modify system processes is the Windows service. And Windows service is a component. Um, these are basically used for the non-interactive processes for the long run. And these processes, they usually handles the OS functionalities. So there are, if you go and look into the tools like Process Explorer or any other tools, then you can see a bunch of services running in the operating system. And a couple of services that you may see there is the DHCP services, and the local session manager services, or maybe the famous WMI services and TCP/IP services. There are many services and hundreds of services that you can see there by default running in the system. So these are all to handle the operating system functionality, so that the operating system will be fully functional while you are using it. And one good thing about these Windows services is that they auto start at the boot time. So whenever you reboot the system, these services which are set to the auto start, they will be starting automatically. And adversaries, they use the tool called sc.exe. So this is the tool that is given by the Windows itself. So they use this utility to modify or create the services in the system. And another thing, additional thing that they can do with the sc.exe is they can load the vulnerable drivers, which will leads to the BYOD, bring your own vulnerable driver. So they can also do that to gain additional privilege in the system. But here we will be talking about the persistence. So let's see how they can register the uh, service in the system. So here is a little application that is just going to print that, okay, hello from the persistent service. So so here, to create the service, one just need to execute this command with the sc and create, and then there is the name of the service and the path location where the that service application is present, and we are just setting it to auto. So whenever the system reboots, it's going to be booted automatically. So this is how easy it is to load the services. Okay, so another technique that we will be looking is the create account. And this is quite a noisy technique that attacker are using. So uh, some of the malwares or threat actors are using this technique to persist in the system as well. So once they have the sufficient privilege in the particular machine, they will create another account. So the advantage over this is that they will have both credentials and access to that user account, and they can survive. Um, they can survive for a long time because they are creating the username on their own. And This will also remove the dependencies of installing the tools which can give you the remote access. So you do not have to, once you have a new account, then you can simply log in into that system with the help of the newly created accounts, instead of just transferring the tool from your machine to another machine. That will also create some um, it can generate some events, and maybe the tools might get flagged as the malicious, so that uh, to avoid such issues they can also create the new account, and then they can persist in the system. However, this is quite a noisy technique as well, because creating an account is quite a suspicious act or event that anyone can perform. And here we are just looking into the sub technique, which is a local account. So local accounts are created whenever you, let's say, install the operating system. Then you will be presented with one local account to manage that particular single system. And in the single system there can have multiple local accounts, but the local accounts cannot be used to manage multiple systems like a domain accounts. So usually threat actors, whenever they gains the access into that system, they, if they have the sufficient privilege to create an account, they will create some genuine looking accounts with a genuine name, like a help center, assistant, staff, or staff one, staff two, something like that. So which will kind of disguise them, but still generating or creating the new account is a suspicious act as well. And in Windows operating system, they may use the net tool to create a account, and it's easy as it is. You can see in the command they are creating a new user just by net user, and this is the username, this is the password, and just forward slash add is going to add a new account in the system. And another technique that we are looking here is the event trigger execution. So events are anything that is generated by the system when some action is performed, or maybe the result of the actions. If you if we give an example, let's say if you are logging into the system, so that's one event. If you are creating the process, that's an event. And so these events so these events can play a very valuable role in the uh, operating system. There are tools like a security tools. They collect those events and try to figure out whether some malicious act is being going on in the system or not. But also attackers, they may abuse the event trigger points to hijack or maybe to execute the shell code while some events is triggered. Let's say screensaver. So if, let's say, your computer is inactive for 10 minutes and you want to set a screensaver, so that event can also be hijacked by the attackers, and instead of the screensaver they can they can end up executing their code as well. So they will find such event trigger point, and then they will point their malicious code to that trigger. So whenever such triggers is going to happen for the next time, the pointed application is going to be executed. So one technique from this one sub technique from this category is the component object model hijacking. So COM objects, they are designed to introduce interoperability and inter-process communication and code reuse. So let's say there are multiple applications running in the system. Some are created in a C++, some are created in a C sharp. And let's say there are a bunch of DLLs which are shared between the processes or applications, but the DLL that are created by the C++ can only be used by the C or C++ applications, but C sharp applications may not be able to use those DLLs or maybe those libraries because of the language independence, sorry, language dependent. So this will break the barrier of the language dependent, and then so also not only the language dependent, but one application vendor can also use the another application vendor's component as well. Let's say if you want to, let's talk about the Excel. So you can simply communicate with the Excel through the COM object, and you can also execute the macro codes through your application. So you can also make those happens through the COM object model. So there are various subkeys that can be used on the COM hijacking. So these are inside the H key current user software classes CLSID, and another location is H key local machine software classes CLSID. So these are the various subkeys that can be hijacked to execute the malicious code. So one example is hijacking the inproc server 32. So in the process monitor, if you filter out the raise open key and then set the path with the inproc server 32, then you can see there is the registry path ends with the inproc server 32. So this is the key, that the subkey that we can hijack, because you can see the name is not found. So first it will go and check in the HKCU, and if it is not there, then it will go and check in the HKCR CLSID, and then it will check there. And you can see right after that it's checking in the HKCR, and it was able to found that in proc server 32 in this particular HKCR register, but it was not able to found that in the HKCU. Now what attacker can do is they can simply hijack this, so that before reaching the inproc server 32 in the HKCR, they can make program execute the they can make a program execute the DLLs from the inproc server 32 of the HKCU. It's because HKCU catch the keys, so that the applications will access these components very fast. But if it does not find there, then it will move to the HKCR. So if you look at here, we actually executed the notepad, and notepad was looking in a catch key that inside the HKCU, that whether there is this component present or not. But it was not present there, so that it was going into the HKCR and trying to find out there. But here what we did was we actually went inside this HKCU, which is the HK current user, and then we created one CLSID because it was not present at the time. And then if you look at here, we also created the inproc server 32, and then we added these uh, keys two values here, and one is with the location of the payload, and another is the threading model, how the thread want to be executed, and we just set it as a both. And next time when we executed the notepad, and notepad spawned our DLLs, and the DLL is just a message box saying hello from CyberWarFare lab. Okay, we can quickly see we can quickly go and see this in the lab as well. So here we already have opened the process monitor. So let's filter out this with this particular setting. So let's go over here and then just select the operation, and let's add this. So here we have added the raise open key, which is correct, raise open key. And in the architecture, and sorry, in the path, we have to make sure that the path contains the, okay, before this I want to make sure that whether the VM is visible or not. Can anyone confirm me? whether the VM is visible or not whenever I'm switching the screen. Okay, we will just add this, and two filters are enabled, so we'll just apply this. Just a second, it was the process monitor was already running for a long time, that's why it's trying to filter out. Okay, we will just clear this and try to open the notepad, and we will pause the event monitoring and let's see what this notepad is generating. Okay, I think the text is quite small, but I do not find any option to zoom this text. But yeah, I'll be mentioning this by word. So here you can see the notepad is trying to open the key, and this is in the HKCU software classes CLS ID, and there is the CLS ID here. This is the ID, and this is the interface ID, and if you can look, there is the inproc server 32, but it is not found there. So we will go to the registry. So we are inside the CLS ID, and we cannot see that that is starting from the 1165659, and I cannot see any keys starting from the 11619. So we can simply right click this and edit filter. Then I will just copy this ID, then just create a new key here. Make sure that the key is exactly the same as the missing one. Then another sub key, which is the in proc server 32. And here in the default, we just have to give the address of the payload. So the payloads are already inside the C payloads and payload.dll. So this is just a simple hello message box, nothing more than that. Okay, let's just assume that attacker has done this, automated this with the script, or maybe it's inbuilt in the applications or the malware itself. We are just trying to simulating this by hand inside from the registry, but attacker, they will come up with the automated scripts to do the same. Now let's just close this notepad and then try to open the notepad again, and you can see the notepad is executing our DLL, saying that Windows persistence hello from the CyberWarFare lab. Okay, so this is how the COM object can be hijacked, but there are a couple of ways to hijack the COM as well. You can go and do your further research on that part, but this is one of the easiest way to do this. Okay, so another technique is the hijack execution flow. So programs are the sets of uh, programs follows the sets of instructions, and it has its own way to execute the commands or maybe the code inside the program. So it follows the sets of instruction in it, but if the attacker is able to hijack those execution, then the attacker can inject or maybe implant something into that execution. So they can simply hijack the execution and make their own script or maybe DLLs or anything execute from that particular process or the program. So some good targets are the DLL hijacking and DLL sideloading, and maybe if there is a weaknesses when you are installing something, if there is a weaknesses in it, then you can also abuse that, the hijack that. And sometimes the file permission weakness, if the attacker is able to delete that file and replace his own file there, then that may also give hijack the execution. And one good hijack technique, and this is a quite a famous one, is the it's a DLL search order hijacking. So Windows, there is a specific way of loading the DLL. So it's just Windows do not just simply go to any random location and pick up the DLL. And DLL are the shared libraries, and it's possible that in one system there may be multiple version of the DLLs lined up there in the machine. So Windows cannot just simply go and pick up those DLLs. Either the programmer has to specify the exact path of the DLL so that the program can load those DLLs. Otherwise, they have to let the Windows to do that, and Windows has its own specific way to locate and load that DLL. But in the while the Windows is looking up those DLLs, if those DLL are missing in such locations, and the adversaries has the access to modify or implant the DLL into that particular location, then they can hijack the execution of that program by redirecting the program to execute their malicious code. So sometimes this will also give the privilege escalation, and sometimes to perform such thing you may also require the higher privilege as well. So we will see why by looking at the search order. So if you look at here, this is the search order that Windows follows when there is the safe DLL mode is enabled. When there is a safe DLL search mode is enabled, this is the flow. So first, there are some preloaded DLLs and the known DLLs. So these are the pre-search DLLs. So we just skip it out because it's already predefined, and then it's going to search those known DLLs like kernel 32 DLL, anti DLL, and some other specific DLLs. It has the path, so it will directly load it from here there. And now let's just start from the application directory. So whenever the program has not specified the full path of the DLL, and it lets the Windows to handle the loading of the DLL, the Windows operating system first try and locate the DLLs into the applications directory. And if the DLL is not there, then it's going to go and look into the system32, and then in the system directory, and then in the Windows directory, and only it will come to the current working directory. And if it is not there, it will search and look into the directory listed in the path in the environment variable. Okay, so the common target to um, perform the hijack is the application directory and the current working directory. But the previously current working directory was on the top, but now it was in unsafe DLL loading. But now current working directory is at the bottom, so we have to go through all these three, and then only after that. If there is no such DLL in any of the four location, only we can place the implant and then execute hijack the DLL from here. But sometimes some applications will be installed in such location where the user has the full right to replace some DLLs or maybe some codes there. So let's take an example here. Let's say we have the maybe Zoom applications or maybe Team server applications. Those will be installed in the another directory, not in the program files, but in the some other app data location. So in such case, the user may be able to place the DLL there. And if let's say if it is looking for, if let's say there are some DLLs that has to be loaded from the system32 directory, which are the already given DLLs from the Microsoft itself. So like debug help the DLL and some other DLLs, it has to be loaded from the system32. Let's say if that DLL is not in the application directory, and the attacker has the full right to uh, place some DLLs or maybe file in that particular location, then instead of Windows going letting Windows to go to the system32.directory and load the debug help DLL from here, the attacker will simply place the malicious debug help.dll, which is crafted by himself, in this particular location, and the DLL is going to be loaded from the application directory itself. So these directory will not be searched afterward. So the DLL is going to be loaded from the application directory itself. And let's say these application directories are in the location where the user do not have the control of. Then in that case, attacker cannot control this. Then the flow will go inside the directory and the system32 directory, system directory, Windows directory. And if that DLL is not into this location, only after that attacker can use this current working directory and then hijack it. But it's a very low chances to get such a thing. But application directory, some of the applications are placed in some folders which can still be hijackable. So here is how you can find the such DLL location. So if you go and set these filters, let's say I'm targeting this GitHub desktop.exe and I'm checking whether the result contains name not found and whether the path contains the DLL. And if it all meets, then we can place the DLL into that location and then we can hijack the execution flow. So let's just put these settings in the process monitor. So let's just untick the previous one and you can see process name is a GitHub desktop.exe and the path contains the DLL and the result is name not found. So let's just apply this and then hit OK. Here's the GitHub desktop and let me delete this for now and let's execute this application. Actually we forgot to monitor this. Let's execute this again. Okay, there is no such configurations to zoom out this theme. Let me try with this. Okay, just look at this first one. So when it is trying to open the file, and you can see it's trying to open the file from the application location, C Windows, and you can see app data local and the GitHub desktop app and the folder app 3.3.14, and then from there it is trying to load the DLL, but it is not found there. So in such case, if the attacker has the permission to write in this folder, then attacker can simply write their malicious DLL. So let me just copy this payload and let me rename this payload to the missing DLL here, which is not found. So currently the user can write into this location without any privilege. So let's just rename this and let me copy this. So this is our malicious DLL and paste it here. It's looking inside from the app 3.3.14. So it's app 3.3.14. We place this here and we will again execute the GitHub desktop. But this time the application will crash. It's going to crash. Okay, let me just close this. And I will open this program again, and you can see it's crashed and nothing is being looked after this because it has loaded. It is trying to find this DLL and it is not finding and loading from the other location. But when it is trying to load the debug help DLL, which is our own DLL that is inside this debug help, this crashed. It's because from these applications, from the DLLs are the shared codes which can be used by the different applications. So this GitHub desktop uh, could be dependent in this debug help the DLL. So it might be looking something from this DLL, and which it is loading our DLL, not the exact debug help DLL from the system32. So that's why we are not able to provide the DLL to provide the DLL code that that the GitHub is asking for. That's why the application is not able to start afterward. So to work around this, there is a way to work around this. One is using the another technique, which is a DLL side loading with a DLL proxying. So we are not going to talk about this here, but this is the DLL side loading is the another technique to which is just I would say that is the refined version of the DLL hijacking. But there is a minor difference between the DLL sort of hijacking and then the DLL slide loading. So we will use the DLL side loading with the DLL proxying. So after combining both of them, we can make the code execute our code as well as its own code from the debug help the DLL as well. Okay, so another technique that attacker can use is the valid accounts. So if you recall previously, another technique their attacker was using was the create accounts. But here attacker can also use the valid accounts. So they can compromise the accounts, like they can compromise the credentials of the different resources like VPNs, RDP, Outlook web apps, access, network devices, and they will try to stay persistent in the system by compromising those accounts instead of creating the new one, and which will drop the suspicious in the system as well, in the environment as well. And another thing that they usually do is they usually look for the inactive accounts. So in the organization there could be many inactive accounts, so they may possibly get hand, or they may compromise those inactive accounts and then try to persist in the system with the help of by compromising those inactive accounts. So let's talk about the technique that is inside this valid account, that is the local account. So here they will abuse the credentials. They will try to dump the credentials of the local account, and once they have the credentials, they may persist in the system as well. And also, if they are lucky enough, then those credentials may work in another computer as well. If it is set up with if it is given the same password in the another computers, then sometimes if they get lucky, then they may get logged into the another system with those credentials as well. And when they get access to the system, and if they have sufficient privileges, they can also enable the inactive administrator account. So normally, if you set up the Windows operating system, the administrator account is disabled, and you have to actually enable the administrator account and change the password to use the administrator. And attackers, they sometimes activate the administrator account and then they change the password of the administrator account, which will allow them to persist in the system by using the administrator user and credential itself. We will look at the example in a couple of slides, not here, because there we have found one malware using such technique as well. We will see it later. But for now, let's just go to the schedule tasks and job. Okay, so most of the operating system they offers the scheduling. So this is the quite a good mechanism that they offer. So let's say we have to do some tasks at certain time or maybe at certain date. So we can the operating system allows us to create a task which is going to be executed at that predefined date, and at the date and time when that date and time comes, the task will be executed. The task could be the program or scripts or anything which we are scheduling there. So attacker, they usually use these task schedulers to persist them in the system. And one thing is that in a Windows operating system, they can also schedule the tasks remotely as well. So one in the Windows system, Windows Task Scheduler is a widely attacked component to remain persistent in the system by the attackers. They use the utility such as schedule scs tasks.exe. Previously, they used to use ad.exe, which is now deprecated. So they use this utility to register a new task, and they can do lots of things, but usually they um, execute their payload at certain time, and they remain persistent in the system. So let's see how the attacker can create a task in the system. So with the help of this schedule task, SCS task, so they will just create. So this is the parameter to create the task, and they will just give the task name and the path to the payload. And here it can be anything, but for this instance we are just setting it as a minute. So we are just saying that okay, schedule tasks and run within a minute. On the basis of the minute, you can set on the basis of the daily, monthly, yearly, however you would like to. And here is a modifier, so we are just saying this, if you just combine everything, then it's just saying that run this program at the internal interval of the 10 minutes, and the starting time is the 11. So after, right after the 11, it will be 11 a.m. Just execute the payload repeatedly at the interval of the 10 minutes. So that's what this command is doing, and we are setting this task as the low persist. It's because to show that even attacker has the low privilege, they can still register the tasks and then make their payload execute, and they can persist in the system. Also, if they are capable of doing the privilege escalation, and if they have the sufficient privilege, then they can also specify the user. um, they can specify the user as they want to execute the payload. And just look at here, everything is almost same, every parameter is almost same, just the ru is being added here. So it's a run as user, and the user that we want, that the attacker, just for now that we want to run this payload.exe, is as the system. So we are just setting that after 11:05 a.m. just execute this mm, payload as a system user, and then right after the 11:05 this task will get triggered, and then the payload will be executed. And you can see the anti-system is there, it's running as the anti-system. So if they have the high privilege, they can do such thing as well. And the final technique that we are going to look here is the server software component. So while developing the large softwares, the developers or the team, or maybe whoever is going to develop that software, they also sometimes give the extensible feature where they allow the users, whoever the user using those applications, can also add the additional scripts or the plugins there. So adversaries, they will abuse this extensible feature of the server software components as well. So they can simply craft the malicious script in a way that the server is going to accept that, and this is how they can remain the persistent in the server component. And one good example is the SQL stored procedure here. So SQL stored procedure is here to avoid the rewriting of the queries. So let's say if you are doing some queries very frequently in your database and you don't want to write the huge long massive SQL queries in the in the SQL, then you can simply create a store procedure which is going to be stored in the somewhere in the database. So you are just going to you are just going to store there in the database, and whenever you have to execute that query, you can execute the store procedure, and which is going to execute your huge massive SQL queries. But here what Microsoft has done is they has also integrated the CLR. So they are also providing the CLR integrations. So if the CLR is enabled there, the attackers can also be able to load the CLR assemblies, the .NET assemblies there in the SQL server. So how adversaries is going to abuse this is that they are going to link the CLR assemblies to the store procedure and then execute the arbitrary code. The CLR assemblies here is going to give the flexibility, so the user can define their own type, define their own functions or routines. So the attackers is going to abuse those in this particular scenario. So here is one example that we found in the lemon duck. If you look at here, they are just creating the assembly evil CLR, and then they are storing these assemblies in the system. They are just creating this assembly and storing that in the database. And then after that, they are just creating the procedure here, and they are creating the store procedure and storing in the database. And right after that, if you look at here, the exec dbo and then the exec command here. The exec command here is the routine that is defined in this assembly code. And from there you can see they are changing the administrator password and they are enabling the administrator. So if you go and look at here, this is what we were talking about, changing the administrator account password and then they activating the administrator account to persist in the system. So just look at this. It's quite a beautiful script that we found in the lemon doc. So they are just creating the procedure with the exec command, and then it's a parameter that they require, which is a command, and the external. So this is going to pass that in the external, which is in a evil CLR, that is the exec command. And from here, this is the command that they are giving it to the store procedure exec command. So if we just go and decompile this binary, you can see the exec command. You can see here, this is what it is being registered as. You can see the exec command, which is inside the store procedure and exec command. So this is being linked here. And in the exec command, this net user administrator is going to feed into this command string, and from there it is going to run the store procedure run command cmd.exe, and the command is fed into this here. So right after that, cmd is going to execute this command, which is going to change the administrator password and activate the administrator and change a bunch of firewall rules. And then here it is it is executing the PowerShell as well. So bunch of stops will happen right after that, and this is how run command is working here. So it's just going and creating a process. So it's just creating a new process with the command.exe with the argument itself, and right after the output is written, it is going to send the output through the pipe to the SQL database. So this is how it is implemented through the stored procedure, and this is one of the good persistent technique that I have seen. Okay, so this is it for this webinar, and thank you for the patience and waiting till this till the end. So three lucky user is going to get the CRT COI seats for free. So this is for this particular webinar. We are providing the three seats for the CRT COI. The three lucky winner is going to get this three seat, and here's more we are providing. So we are having a CCDA course launch this Friday, which is the 26th April, and here we are also giving away 5 CCDA certification seats. So what's inside this course is going to be discussed in the webinar itself. So everyone, if you have not registered in this particular webinar, please go and register, and whatever is inside this course is going to be mentioned by the instructor himself while in this particular webinar. And 5 lucky people is going to get the 5 CCDA certification seat, and this is only valid when you join this particular webinar. And for joining this webinar, you will be getting a 3 lucky user will be getting a 3 seat for the uh, CRT-COI certification course. Okay, so here are the reference. You can go and further look into those techniques, and also go and try to find out which malwares are using what sort of techniques. So MITRE framework is a quite a structured framework where you can find lots of details and you can do your further research from there. And thank you everyone for joining this webinar. And the attendance certificate will be there within 48 hours in your email. So if you have any queries, then you can ask. Okay, I'll just copy the references and then send it to you. But you will be also getting the slides. So yeah, you will be having the access to the presentation. Okay, the tool that it was used in this webinar was the process monitor. It's a procmon from the sys internals. The recorded video will be uploaded very shortly, and you may be getting update in the email as well. Okay, the winners will be announced very soon. So keep looking at the LinkedIn profile of the CyberWarFare Lab. Okay, I'll be waiting here for 3 minutes. If you guys have any questions, you can drop the questions here. And I hope this is quite a fundamental description on the persistence. So I hope you guys enjoyed this session. About the discounts and other course details, you can message in a support or email in a support of the CyberWarFare Lab, and the support team will reach out to you. It's not a hidden admin account. It's the default administrator account which is inactive. Just a second, I will be forwarding the link to the next webinar. Okay, so yeah, if let's say if they have a hold on the user account, and if you have the admin privilege for that particular user. So administrator account and the privilege is a different thing. So let's say if you have just a normal user, and you can have administrative right. So if you have a right to not just a normal integrity, but if you have a high integrity, and if you have a quite sufficient level of the tokens for that particular user, then yeah, definitely you can activate uh, the that hidden, sorry, not hidden, but the inactive administrator accounts. But but it has to be sure that the user account has the high privilege. Okay, quantum builder for initial access, and normally the first payload is never detected, but the second and thirds are detected. Okay, so I have not used the quantum builder, but the case could be the initial for the initial access. Let's say it could be encrypted or maybe obfuscated. At this point, I have not used this quantum builder, but let's just suppose that the quantum builder is creating something that is not detected at the first payload, which means that the payload might be good enough, like maybe the encrypted or maybe good enough to uh, the evade the detection, but during the long chain, so there is a bunch of kill chains there. Let's say you go with the initial access, or you may have to do something, you have to do the enumerations, or based on the goals that you want to achieve, based on the stuffs that you want to achieve in while doing the operation, there may be chances that the second and third payload may be leaving some traces which may be detected. So there is a, let's say you have a, let's just talk about, I'll just give you the simple example in this case. Let's say you have a one payload and you encrypted that, and then so let's say that is generated by the metasploit or MSF Venom. So you encrypt that and then you make that obfuscated and you do everything to make it undetectable. So at first instance you will be able to execute that and it will not get detected. But right after it's trying to connect to the C2 or any other thing, then those events or behavior might be recorded already. So those events may be suspicious for the any security tools that is present there. Okay, so I'll be dropping the the link for the second webinar, which is happening in the 26th April in Friday. So make sure you all register on that email and try your luck to get a seat. So 5 lucky user is going to. Okay, can anyone confirm that the link is there in the chat? For the talking, I cannot see the option to unmute, and also I think mm, these rules are not set. I'm not sure about it. Yeah, but if you want to, if you have some queries, then you can connect me on the LinkedIn as well. Okay, now can anyone confirm that the URL is received to everybody's DM? Okay, it's because of the UI of the. Okay, within 2 minutes I'll be closing this session. I hope you all get the link to the second webinar. And thank you everyone for having patience and then watching this session. Also, just keep checking in the LinkedIn. Maybe we will be reposting the event one more time in the wall, so you may able to reach out to the link as well. So I'm now ending the session, and good luck everyone.